Behind every complicated signal, hidden waves are quietly oscillating. The Fourier Transform reveals those invisible frequencies and reconstructs the mathematics hidden inside chaos. First, the computer observes the raw measurements. At different moments in time, it records sampled values from the signal. The data appears irregular and chaotic. No obvious structure can be recognized directly. To the scientist, the signal looks like a mysterious collection of numbers. But hidden beneath this apparent randomness, invisible oscillations may already exist. The computer now becomes a frequency detective. It selects a test frequency, omega equals 1, and creates the rotating detector wave. At every sampled moment, the signal value stretches the rotating vector in the complex plane. Then all vectors are added together. Most of the vectors point in different directions and cancel one another. The final accumulation is very small. The scientist concludes that frequency 1 barely exists inside the signal. Next, the computer tests another frequency, omega equals 2. Again, every sample interacts with the rotating detector wave. But this time something remarkable happens. The vectors begin aligning. Instead of canceling each other, they reinforce one another. A large accumulation suddenly emerges. The scientist immediately recognizes the meaning. The signal strongly resonates with frequency 2. The computer continues scanning many possible frequencies. Most frequencies disappear into cancellation. Their contributions remain weak and insignificant, but several strong peaks survive. Now the hidden structure of the signal begins revealing itself. What once appeared to be random noise is actually a combination of multiple oscillating waves layered together. However, the scientist understands an important detail. The raw Fourier values are not yet the true amplitudes of the waves. Because many samples were summed together, the magnitudes became artificially large. So the computer normalizes the coefficients. After scaling, the true strengths of the hidden frequencies finally appear. The invisible oscillations now have meaningful physical amplitudes. Now the computer rebuilds the hidden signal. For every important frequency, it creates an oscillating wave with the correct amplitude and frequency. A strong, slow oscillation appears. A weaker, fast oscillation emerges. Higher frequency vibrations are added as well. Then all waves combine together. Suddenly, the apparent chaos transforms into structure. The mysterious measurements now reveal a clear mathematical form. But the scientist must still confirm the reconstruction. The computer compares the original sampled data with the reconstructed signal. At every sample point, the difference between them is computed. The errors remain extremely small. The reconstructed waves reproduce the original measurements almost perfectly. The scientist finally realizes that the hidden oscillations inside the data have been uncovered. This is the essence of the Fourier Transform: to discover hidden frequencies inside complexity and reconstruct order from apparent chaos.